Hello there, ROS developers. Welcome everybody to a new open class. Today we have a quite special open class. We are going to be talking about ChatGPT, but more specifically, we're going to be introducing today a new series of classes that we are going to be doing during the following weeks related to ChatGPT. Yeah. So today we are going to do open class number 171, which is titled using ChatGPT for robot programming. So basically this is going to be an introduction of a series of classes that we are going to be doing, where we are going to talk about how you can use ChatGPT for your benefit in order to program robots better and faster. Yeah. So yeah, welcome everybody. Then let me have a look here at the chat. I want to make sure that everything is right, that video is right, sound is right. I can see hello from Utah, hello from Barcelona. Good afternoon from Munich. Sound and picture is wonderful. Australia, so we have a quite international audience today. Also Canada. Awesome. All right, so welcome everybody, and let's not lose any more time and let's go into it. So let me already right now switch to my computer screen. There we go. So are you all new to these open classes? Have you attended any previous open classes? Is this the first one? Are you already veterans? How is that? So actually I'm going to move here to the open class page, because this way I'm going to have the chat right here. So actually there I can see you all. Already attended some classes, says Andreas. I am new, okay. So, okay, what are these, in case that you are new, let me just very quickly introduce. So, open classes are not classes which are intended to have you there just watching and listening to what I'm explaining, all right? But open classes are intended to be interactive and practical, okay? So I want you to get involved and to practice alongside with me, all right? Then for that, in that purpose, the first thing that you need to do is to get the class rosject, okay? The class rosject is an integrated project where you are going to have basically the same environment as I'm going to have, so that you are going to be able to reproduce anything that I am doing, all right? Then, how can you get the class rosject? Very easily. All you have to do is to click on this button that you have right above the chat here. It says fork and open the class rosject, all right? I'm going to click here myself just to demonstrate what you are going to get, all right? Then, as soon as you click there, you are going to be redirected to the rosject main page, okay? As you are seeing right now, for me, that I have been redirected here, then here in the right side, you have the streaming panel, all right, which you can minimize, you can move it to a different tab if you want. All right, there we go. Okay. All right, there we go. Yep, and then, as you can see here, the environment is going to take a few seconds to load. Mine is, you can see here that it's still loading, and as soon as it finishes loading, you are going to be able to have access to the full project. Let's say, okay, this is an online environment where the first thing that you can see here is a notebook. All right, in this notebook you are going to find all the instructions and everything that I'm going to be explaining, any lines of code that you need to execute, etc. You are going to find everything here. Okay, so this is going to be the reference I'm going to be following in order to deliver today's class. All right. Then, actually, let me come here. Let me go back here to the class. I'm going to leave this here opened. Hello from France, hello from South Africa. So let me know, have you been able to open the rosject so far? Yeah? Is everybody in the rosject environment as I am here? Yes, no? Any problem so far? Joshua says yes. Thomas says, hi, this is my first time to join. I have tried to use GPT for ROS2 for a while. Right now I am facing question to check the node status to see whether it is there or not. It gives some not exist, F. Okay. Yes, yes. Okay, so I understand from your comments that all of you have been able to get the rosject and have your rosject opened here, right? Then let's continue with the class, all right? So today's class is about ChatGPT for robot programming, but basically the purpose of today's class is to introduce a little bit ChatGPT in the world of robotics and to introduce the different points in which ChatGPT can help you boost your robotics development level. Yeah. So first of all, what is ChatGPT, however? Yeah. So you might be asking, okay, yeah, very well, Alberto, but what is ChatGPT? Does everybody know what is ChatGPT? At this point, I'm going to guess that most of you know what is ChatGPT and probably have even used it, right? Yes, yes. Yeah, so ChatGPT basically it's a chatbot that is able to answer almost any type of questions, and it answers them in an, let's say, a human-like way. Yeah, so it's very similar as how a human, you would have a conversation, an online conversation with a human, right? But basically ChatGPT at the end, it's an application, yeah, which is built on top of GPT. In this case, 3.5. I think there is already a version which is superior, yeah, but the default one, the basic one, is based on GPT 3.5. And what is GPT 3.5? Well, GPT 3.5 is basically a language model. Yeah, the GPT letters stand for generative pre-trained transformer. Yeah, so basically it gets as input words, and it is able to understand these words and generate an answer that makes sense. Okay. And on top of that, there are some AI training in order to fine-tune some things and so on. Okay, but basically this would be a simple definition of what ChatGPT is. Okay, but the thing is that ChatGPT is a language model, but this language is not restricted only to human language. Yeah, but GPT can also understand computer language, yeah, and this is the interesting thing, especially when we want to apply ChatGPT or GPT to robotics, yeah. Then, how can ChatGPT help us in programming robots better and faster? Yeah, so there are many ways in which we can take advantage of ChatGPT. But for this series, we would like to focus on the three that we consider most important, okay? And they are going to be divided into three different classes, yeah? So after this one, which is the introductory class, we are going to do three additional classes, each one of them dedicated to one of these points. So the first point is how to use ChatGPT to program ROS robots faster. Yeah? What do I mean by program ROS robots faster? Well, ChatGPT can help us in speeding up the velocity at which we create programs. Yeah, programs that otherwise it might take, I don't know, maybe 1 hour to have them ready working. Properly using ChatGPT, we can have these programs ready in, I don't know, let's say 10 minutes. Yeah. So how can we speed up the process of creating a robot program? Yeah, this is going to be the focus of the first class, and today we are going to see a basic demo on this. Yeah. Then the second point is using ChatGPT to debug ROS errors faster. Okay, so as robotics developers, one of the things that is going to take most of our time is debugging and trying to figure out what are the errors, what are the problems in a ROS program that is not working as expected or as intended. Yeah, this is one of the things which is more time consuming for robotics developers, and ChatGPT can also help us in this. Yeah, it can help us in being able to analyze faster and finding these errors or even potential errors in our programs faster. Okay? So this is the second point, which we are going to treat it more in depth in class number 2. And finally, the third point is using ChatGPT to understand third-party ROS code faster. What does this mean? Well, also as robotics developers, it is very common and very often we are going to find ourselves reusing code that other developers have created. Right? In fact, this is one of the most powerful points or features that ROS provides, is this ability of being able to reuse code which has been developed by other teams, and we can take that code and use it into our robot with minimal changes. Yeah, this is one of the most powerful features that ROS has bring to the robotics community, right? But sometimes it can be hard and also time-consuming trying to understand code that has been developed by others and getting to really understand how it works inside. Yeah, and in this sense, ChatGPT can also help us in speeding up the process of understanding a third-party code, ROS code faster. Okay, so these are the three main points that we consider ChatGPT can help us a lot in our robot programming. Yeah, it can help us create better programs, and it can help us create them faster. Yeah, so at the end, it's going to make us better robotics developers, right? However, in order to be able to use ChatGPT for our advantage, we need to know and understand how to properly use it. Which are the strong points, which are the weak points, which it has, obviously also. So we need to know how to properly use ChatGPT in our advantage. All right? And this is going to be the purpose of this series of classes. Then today, as I already said at the beginning, we are not going to get in depth into all of this, but we are going to see some basic examples of each one of them in order to get an introduction and an example of how ChatGPT can be helpful for us. Yeah? So far, so good. Any questions? Any comments that you would like to share before we get started? I'm going to actually minimize this. Yeah? Is it clear? No questions? All right, then let's just get straight into it. Okay? Again, could you show me again how to access the PDF file? Thanks. Says, yeah, well, actually, this is not a PDF. GTN. This is a notebook. Okay, and in case that, so it should automatically open for you once you access the rosject. In case it didn't automatically open for whatever reason, you can open it here. Yeah, here in the bottom right side, you have all these icons, which we are going to be using in a moment. Yeah, and here, in this case, the third one, it says Jupyter Notebook. If you click here, you are going to be able to see this notebook that I have here opened. All right? It's clear, everything clear so far. Great. Then let's get started. So let's start by setting up a simulation, right? So we at the Construct always think that the best way to teach is by doing, yeah, with practical examples. So everything that we are going to be doing today, we are going to apply it here to a real ROS2 simulation. All right? Then the very first thing that we are going to do is to set up the simulation, to start the simulation. And for this, we need to execute a couple of commands here in a shell, in a terminal. Yeah? Then how do we open a terminal? Well, very easy. We come here to the bottom right side where we have all these icons, and we are going to click on the first one, which says Web Shell. Yeah, I'm going to click here myself, and this is going to open a brand new empty Linux terminal. Okay? Then here, all you have to do is to copy these commands, yeah, and paste them directly to the terminal. Okay? There we go. Then this is going to start this, if everything goes okay, in a few seconds, we should see this simulation popping up. Here I have already the gazebo window popping up, and now I have to wait a few seconds until the simulation is fully loaded. Okay? Let's see. So if everything goes okay, I should have something similar to this in my gazebo window. All right? Let's see. Gazebo usually takes some seconds to load because it needs to start. It needs to load all the models and visual elements, which take some time. But there we go. So here I have my simulation. This is a Robotics robot. Specifically, this is the MP400 model from the Robotics, which is a mobile robot base, as you can see. And here we have it in a simple environment here with a ball and some closed circuit here. Okay? So all of you should also be able to see this simulation with the robot here in the middle. Okay? So let me know if you have been able to load the simulation properly. Here says, Thomas says, for me it works fine. Okay. Awesome. So I want some more feedback for others, because I want that all of us can work with the simulation. Okay, Jill Mady says works, also Giovanni, all good so far. Okay, excellent. Okay. All right, then let's get back to the notebook and let's continue with the points. So, yeah, by the way, here I didn't mention it, but you have it here in the notebook as well. So if you want to learn a little bit more about ChatGPT, I have left here a link to a podcast that we did some months ago talking about ChatGPT and how it affects the robotics world. Okay, so if you are interested, you can just give it a look here. It's quite interesting. All right. Then also here you have a link to ChatGPT. Yeah. So in order to use ChatGPT, you can click here in this URL that I have shared here, and this is going to take you directly to the official ChatGPT page. Okay, you might need to log in. Here I'm already logged in. Okay, and you might, in your case, if you are not, you might need to log in. But well, you can log in with your Google account, for instance. Yeah. So yeah. Then let's get started. So a few moments ago, I was discussing about the main points in which ChatGPT can be helpful for us in order to make us better and faster robotics developers, right? And the first point that we were discussing was using ChatGPT to program ROS robots faster, okay? Then we are going to start by doing a quick demonstration of this, yeah? So in this sense, there are also many ways in which ChatGPT can assist us and provide us help in order to generate programs and to develop faster, okay? But one of these points, and probably one of the most interesting ones, is that ChatGPT can create actual programs for us, yeah? So how does this work? Well, we provide a prompt to ChatGPT explaining what do we want, yeah? And then ChatGPT outputs, it provides directly a program, yeah? Then this has, we have to be a little bit careful with this, but in any case, as I said in this class, I'm not going to get into all the details, yeah? All those are going to be discussed in the next class, which is going to be class 1. So here we are just going to do a quick demonstration. So how can I use this feature? Okay, so here we have an example prompt for ChatGPT, which says, write a program for ROS2 in Python to move a robot forward during 5 seconds and then stop. Okay? So what I'm going to do is to directly copy this prompt here. I can't, let me copy it like this. Yeah. Okay, and then here, what you have to do in ChatGPT is to open a new chat. Yeah. So let's just start a new conversation with ChatGPT. All right. And then here you are going to see a box in order to send a message. Yeah. So here I'm going to directly paste the prompt. Yeah. Which says, again, I'm going to repeat, write a program for ROS2 in Python to move a robot forward during 5 seconds and then stop. Okay. Actually, this could be 4. Yeah. And then I'm going to send this message to ChatGPT. Let's see what happens. So it's going to take some seconds to think, and there it goes. Okay, it's still generating the output. Let's give it some final time here. Okay, so as you can see, it has provided a quite extensive answer. Yeah, it even suggests me the command to create the package. Here it provides the code. Yeah, which we can analyze. It's creating a publisher for the command belt topic. It's looking good. Okay. Then it says you should make it executable as well. In order to compile it, you should use this command and so on. Now, one interesting thing about, well, interesting, but also one point which you should be careful with is that ChatGPT might not, and actually probably it's not going to provide you the same answer 2 times. So if I send the message again, or if I remove this conversation, let's say, and I start a new one, and I use exactly the same prompt, it is very likely that the program that it generates this time is going to be different from the previous one. Okay? Let's see what it tells us now. Actually, here in the rosject, you can see a provided code by ChatGPT. Yeah, this is one that it provided to me during my test previously. Yeah, which is setting up a class named forward motion. Yeah, here it has a timer and the publisher for the common bell topic. Here it has the timer function. Okay. What's going on? Ah, there it goes. It took some more time. Yeah, so it's to create a ROS2 Python program to move a robot forward for 5 seconds and then stop, you'll need to use the ROS2 framework and the appropriate packages for controlling. Okay, here it's providing me another. See, so now the answer is different. Okay. See, and the program in fact is completely different. Here, for instance, it's not using a class. Okay, I'm going to still generate a third one, and then I'm going to use that one. Python to okay. Let's see a third output. Let me read here. I have some errors saying a model is missing, but it still loads. Ah, yeah, don't worry, Cyril. I also have these messages here with the models. Don't worry, you can ignore them. As long as you can see the simulation loaded here, you are fine. Okay? Yeah. Then while here it's generating the output, let me just explain you here that for this example, I have already set up a ROS2 package. Okay, so that you don't have to generate the package and everything. Yeah. Then here, in order to see this package, you can open the code editor here in the rosject. Okay. Where is the code editor? Well, you are going to find it here, right next to the web shell icon. Here in the right side, you can see the icon for opening the code editor. I'm going to click here myself, yeah, and this is going to provide you a visual code editor with access to all the folders, files, and everything that this rosject contains. Okay, in this case, we are interested in the ROS2 workspace. All right, and here inside the src folder, you are going to find this package named GPT tests. Yeah, there are other two packages, Robotics ROS2 and T3 Foxy. Okay, these packages are related to the simulation, so you can leave them there and ignore them. Yeah, and this package, GPT_tests, is a package that I have already created in order to test our codes. Yeah, so in order to test the code, we have here this moveforward.py script. Okay, which right now it is empty. Okay. So what we are going to do in order to test the code provided by ChatGPT is to copy it and paste it directly. All right. So here I have my example. Yeah. Let's use this one. To create a Python program for ROS2 that moves a robot forward for 5 seconds and then stops, you'll need to use the ROS2 framework and interface with your robot's hardware, assuming it has a ROS2 interface. Here's a simple example of how you can achieve this using Python and ROS2. Okay. So here we have a sample code, which actually this one looks pretty similar as the one I was using. In any case, I'm going to copy the code directly here from ChatGPT. Okay? So I'm going to select the code, or you can copy directly with this. Copy code, and I'm going to paste it here to Control V. There we go. Okay? Yeah? Now, let me go back to ChatGPT. So here, besides providing me the code that I have asked, that I have requested, if I keep reading here, I have some additional explanation related to the code. Okay? In any case, let's go back to our rosject. Okay, so very well. I mean, ChatGPT has created the code for me. At this point, it is already quite impressive, but is this going to actually work? Okay, so the only way to answer this question is to test it, is to try it, right? So for this, what we are going to do is to compile and execute this program. Yeah, and we are going to verify if it works with our simulation, with our robot simulation. So let's open here a new shell. Okay, this one we are going to leave it here running. Okay, the first one, because this is where we have our simulation running. So if we close it, we are going to kill our simulation. Yeah. So instead of that, what we are going to do is to open here a new terminal. Okay. Here you have a button to create a new terminal. There we go. And then here we are going to compile. Okay? Remember that in order to compile in ROS2, the command to use is call build. Okay? And if I want to compile a specific package, I can use the packages select. And it's GPT. Let me change this. GPT tests. Yep. Okay, so it has finished. Source. Okay, and now in order to test the program, I have the ROS2 run GPT tests and move forward node. Okay, this is the node name which I have set up in this package. Yeah, if you come here to the setup.py, you can see that I am generating here this node from the move forward Python script. Okay? Yeah, from this script here, I am generating this node. So if I want to execute it, I need to run this node. All right? Then let me execute this. Let me put this a bit smaller here. And let's see what happens. So the robot should start moving. And there we go. So the robot is moving forward. And after 5 seconds, it stops. Okay? So apparently this is working. Let me stop the program. Here there are some errors with the shutdown of the node. Yeah, so as you can see, the program is not perfect. But let me run again and verify. So it's 1, 2, 3, 4, 5, and the robot stops. Okay, so apparently the program that ChatGPT has written for us works as intended. Yeah? So probably if I had to create this program myself from scratch, it is not a very complex program, but it would have taken me probably at least, I would say, 10 minutes. Okay, to write everything line by line. There are many things that you don't remember. Okay, so how do I create a publisher? What is the message used for the command belt topic? I would need to refresh some things, yeah? Then with ChatGPT, I can get something working as fast as this, okay? Now, again, I'm going to repeat this. It can happen that the program generated by ChatGPT doesn't work. Initially, you need to do some modifications. All these things can happen. Yeah, so you have to be careful with this. But in any case, it can still speed up a lot the process of developing, okay? So I'm not going to get into all the details now, okay, because this is just a quick demonstration, yeah? But we are going to we are going to get much more deep into this in the next class, yeah, which is going to be class number 1 of this series on using ChatGPT to program ROS robots faster, okay? In this class, we are going to take much more time to analyze the examples. We are going to create more complex examples. We are going to see other ways in which we can also ask ChatGPT for different things, yeah? But all that is going to be in next class, okay? So, yeah, let's move to the point number 2 now. But before that, let me know. So have you been able to generate your programs with ChatGPT? Have they worked on the first try, like mine? it can happen that it doesn't work on the first try, okay? So keep that in mind. During my test, it happened a couple of times that the code didn't work on the first try, and I needed to do a couple of minimal modifications. Just need some more time. What was the command exactly? The command for what? Joshua says, work it on the second try. Okay, that's really nice. That's really nice. Oh, to execute the code. Yeah, to execute the code, the command is ROS2 run GPT tests move forward node. Okay, let me paste it. I'm going to paste it if you want. I can paste it here in the chat. Work it. For Andreas Binder, also work it. Nice, really nice. Okay. All right, let me just... Oh, Cyril says, ChatGPT currently saying we're experiencing exceptionally high demand. Please hang tight as we work on scaling our systems. Yeah. Okay, Cyril. Yeah, sometimes with the free version of ChatGPT, that happens. Yeah, that the servers get overloaded, and then you have to wait a bit for it. Okay, so that's normal for the free version. And probably there is so much people here in the open class trying it right now that you guys are breaking ChatGPT. No, just joking. All right, then let's move to the second example, okay? Which was, let me remember, using ChatGPT to debug ROS errors faster. Yeah, so this is another area in which GPT can be very helpful. Yeah, in helping us find bugs, errors, potential issues in our code. Okay, then here, in order to find bugs in the code, we can do it in a very similar way, which is to pass the following prompt to GPT. Find bugs in this ROS2 node, and then we paste the code right below. Okay, this is how we are going to do it right now. In this case, I have an example which is based on the previous code. Okay, so here it was generating a code, and then here on purpose, I introduced some errors. Okay, so I'm going to do the same, but now I'm going to do it with the code that it has provided to me the second time. Yeah, which is similar, but it's actually not the same. Yeah, if you check the code I had here, yeah, you can see it's not quite the same. Yeah, here I have an if-else, which I don't have here, for instance, and well, okay. In any case, I'm going to use this one, the one I have in the demo that I am doing right now. So I'm going to introduce here a couple of errors on purpose to this code. For instance, let's see. Okay, so we can introduce here a first error, which is a typo. Okay? For instance, especially for ROS beginners, it can be very common to write typos. Then here we are declaring our publisher with an underscore, as you can see at the end. Yeah? Then, for instance, I'm going to remove this underscore from here. Yeah? From here, I'm going to remove this underscore. All right? And let me try to introduce another error. Okay, for instance, another very typical error that beginners make is that they don't properly access the values of the twist message, which is done like this. Yeah, you generate an instance of the twist message, and then you access the linear x value. In this case, this is to move it forward. Yeah. So, for instance, I'm going to, on purpose, remove this. Okay. Yep. And then, for instance, I can try to send this code. Well, actually, let me. I can show this, and you're going to see that it. I don't know if it's going to even compile. Let me try. Okay, so this compiles, but if I try to run it now, you are going to see that it does not work. Okay, move forward node. Yeah, so this is not working. Okay, then let me ask ChatGPT. So let's use the structure which I have indicated here in the notebook, which is find bugs in this ROS2 node. So let me ask this. Find bugs in this ROS2 node. 2 points, and then right below, I'm going to copy and paste my program. There we go, copy and paste. And then I submit the message to GPT. There we go. Okay, and there it comes. It says, I found a few issues in your provided code. Okay, first of all, in the moveRobot method, you are trying to set the linear velocity of the twist message using linear x, but you forgot to specify the object to which it belongs. It should be twist message linear x. Okay, okay, very well, ChatGPT. You got me on this one. So let's follow ChatGPT advice, and let's change this back to this. So twist message with the proper indentation, twist message linear x. Okay. What else? In the moveRobot method, you are trying to publish the twist message using self-publisher. But you defined the publisher as self-publisher underscore in the init method. So you should use self-publisher underscore publish twist message. Okay, very well. So far it has detected the 2 mistakes that I have introduced, right? So let me also change this here and put it back to what ChatGPT says. Very well. Here it says, there is a missing import statement for the RCLP shutdown function. You should import RCLPy. Okay, here, for instance, you can see here, it's saying that RCLPy import is missing, but it's not, unless, yeah, so actually it's there, the import. Yeah, so as you can see, ChatGPT is not perfect, okay? So it says, hey, you are missing this import. You can come to the code, you are going to see that it's actually not missing, so you just ignore this advice. Yeah, and furthermore, it provides here a fixed version of the code. Yeah, so I can even copy this one, the one that ChatGPT provides, which actually it's the same that I have done. Yeah, and now if we recompile this, I'm going to recompile. And run it again, and now I should expect that the program is going to work again. And there we go. So we have the program back working. Okay? All right. So what have we seen with this example? Well, that we can provide a code which is not working to ChatGPT, and ChatGPT is going to analyze it and find bugs and errors in this code. Okay? Now, we have also seen that we have to be careful with what ChatGPT tells us, okay? So we cannot just believe everything it says, yeah? Again, this is just a simple example, yeah? So in class number 2, we are going to analyze this feature more in depth, which are, what are the things that we have to be careful with? We are going to work with more complex errors, etc. Okay? But that is going to be for class 2. So yeah, for now we are going to move to class to point number 3. Yeah, which is using ChatGPT to understand third-party ROS code faster. Okay. Before that, let me check the chat one more time. Any questions so far? Let me see here. It's working. I have setup tools error. Yeah, don't worry, Martin. I also have this warning here. Setup tools deprecation warning. It's not an error. It's a warning. Okay, but you can ignore it. You can just ignore it. Don't worry about it. It's building the code fine. Thomas says, Sorry, I have to leave now. I'll repeat the class for sure. Keep on. Okay, Thomas, no worries. Hope to see you in the next class as well. All right, then let's continue with the third and last point, which is using ChatGPT to understand third-party ROS code faster. Yeah. So in this matter, ChatGPT is also very good and can be very helpful in explaining how a code works on the inside and what's the purpose of that, in this case, that ROS2 node or program. Yeah. Then in order to demonstrate this, we are going to go directly to the ROS2 demos official repository, which you have the link right here. Yeah. So let's open this, and here you are going to find many different ROS2 demo codes for different things. Okay. For instance, I'm going to select one related to the action tutorials, which are a bit more complex than the codes that we have been working so far. Action tutorials in Python, for instance. And inside here, we can open the Fibonacci action server.py, which is the demo action server provided by ROS2, the default one, the typical one. Yeah. And then what I'm going to do is to directly copy this code here. Okay. Or you can select the code, copy, yeah? And in this case, I'm going to ask GPT the following. Explain this ROS2 node, and then I'm going to paste the code, yeah? So let me go back to ChatGPT and write here. Explain this ROS2 node. 2 points, and then I paste the code here and submit the message. There we go. Let's see what ChatGPT tells us. Okay, I have picked this one. You can pick this code, or I just have picked this one because it's the very typical Fibonacci example that probably most of you know if you have some experience in ROS, but you can pick other codes. In fact, I encourage you to try different codes that you find around here and ask ChatGPT to explain them to you, because here you have many different codes that do many different things. Yeah, so we can see here it's taking some time. Probably this is related with the servers being having lots of requests. Let's wait a bit more. Hopefully we can finish with this last demonstration and it doesn't tells us to wait. There we go. Okay, so there it's coming. Okay, we can see that it's providing a quite extensive explanation. Let's start reading a little bit. So it says, this is a ROS2 node written in Python that implements an action server for the Fibonacci sequence calculation. The Fibonacci sequence is a series of numbers where each number is the sum of the two preceding ones. Okay, let's break down the code step by step. The script starts with a shebang that specifies the Python interpreter to be used. Very well. The script includes copyright and licensing information. Okay. 3. Import necessary modules. Time. Use it for introducing delays in the code. Action tutorials, interfaces, action Fibonacci. Import the action message type, Fibonacci, from the action tutorial interfaces package. RCLPy, the ROS2 Python client library. RCLPy, action server. This class is used to create an action server. It keeps going. Define the Fibonacci action server class, which inherits from RCLPy node. Yeah? So it's going basically line by line explaining all the code super detailed. Yeah? So it's explaining me all the imports, what each import is doing. Here it's telling me that it's creating the class which inherits from node. Yeah? This class is responsible for creating and handling the Fibonacci action server. In the constructor, it initializes the node with the name Fibonacci action server. Yeah, this is this line right here, line 39, yeah? It creates an action server using RCL-Pi action server that handles the Fibonacci action message. The action server is named Fibonacci. Yeah, we can see it here, the name of the action server, which is Fibonacci indeed. So I can keep going and going, but basically you can see that it has analyzed it and understood very well what the code is doing, and it's provided me a very detailed explanation of the code. Yeah, I could have understood the code if I looked at the code myself, yes, but probably it would have taken me much more time to go line by line, understanding everything, and instead, here I can just read what ChatGPT tells me, and I can analyze and verify everything much more faster. Okay? So, yeah, try it yourself. Let me know. Have you tried it with the Fibonacci code? Maybe with another example of the ROS2 demos? Yeah, have you been able to test it properly? And did it provide a correct explanation of the code? Yes, perfect, says Martin. Joshua says, is there any value in using the GPT-4 Python sandbox for better code writing and debugging compared to GPT 3.5? Would that be better, or are they equal in their output? To be honest, to be honest, I have not tested with GPT-4, but in theory it should be better. It should be better to use GPT-4 because it's more updated and it has much more knowledge, if you want to call it like this. Okay, so in theory, using ChatGPT should be better and should show some improvement with respect to ChatGPT 3.5. Okay. All right. Yeah. So this was the final demonstration for the point number 3. Yeah. And then just to finish very quickly, let me remind you or explain you, in case that you didn't know, that recently we have added a ChatGPT tool here in our system that you can use also directly by clicking on this button. Yeah, and you can use it, for instance, very easily to explain code. I can show it here with the Fibonacci also. Yeah, so I paste the code here and say, okay, explain code. There we go, yeah. You have the details here as well in the notebook. See, it's analyzing the code, and when it finishes, it's going to provide me the explanation of the code. Yeah, there you go. Yeah, so here you have the explanation. This code is an example of an action server in ROS2 using the Fibonacci action interface. The Fibonacci action server class is a subclass of the node class. Yeah, so here you can see that it's explaining me, and you can, in fact, see that the answer is different. Yeah, here, for instance, it's much more detailed. Okay, this depends on many factors. It depends on the prompt. Yeah, but we are going to analyze all this much more in deep in the next classes. Yeah, so for this class, let me summarize. For this class, I wanted to provide an introduction of how can ChatGPT help us in programming robots, and introduce the 3 main points which we consider are most important in this sense, which are that how to use ChatGPT to program ROS robots faster. This is the first point. Using ChatGPT to debug ROS errors faster. And finally, using ChatGPT to understand third-party ROS code faster. Okay? These are the 3 main points that I wanted to introduce in today's class and show a simple demo of each one of them. And then In the next classes, we are going to get much deeper into all these subjects, okay? Next class is going to be about how to use ChatGPT to program ROS robots faster, okay? So stay tuned in case you are interested and want to learn more. And there we are going to see many more things. Also, we are going to deal how to write better prompts, yep? Because the prompts that you provide to ChatGPT are going to affect a lot in the output you end up getting, all right? So let me read these last comments. Andrea says, I was trying this with my own local ChatGPT using code Yama, and it worked as well. Nice, really nice, Andreas. Thomas says, I have asked GPT-3, it say it only up to 2021, and ROS2 Galactic. Exactly, Thomas, yeah. So GPT 3.5, GPT-4, sorry, in theory, well, in theory, no, it has knowledge which is more updated. Yeah, and this for a language like ROS2, which is being improved constantly and very quickly, it's important, of course. Well done. I have ROS1. Do I update it to ROS2 or no? Please give me an answer. It depends. Short answer, yes. If you can, I would move to ROS2. But it depends on the specific case, on each specific case, okay? All right, then let me already leave it here. I hope to find all of you that you were here in the class in the next one where we are going to be analyzing all these much more in deep. So yeah, thanks a lot for being here with me during this class. I hope that you enjoyed it. I hope that you have learned something new, and I hope to see you all in the upcoming classes. So yeah, as always, keep pushing your ROS learning and take care. Bye bye.